Hi, this video goes through the answers to the logarithmic practice problems with a little bit more explanation in case you needed to check your answers and go through this refresher here. Okay, so again, reminding you that when we ask for this first number here, we write into exponential form. Okay, all I'm asking for is a final answer in the form x to the power of n is equal to a, right? So you don't need to show me any steps if you don't want to, right? Ultimately, that's what I'm looking for. So if we look down here, a little zoomed in, okay, I have log base 2 of 4 is equal to 2, right? And what this is essentially saying here is 2 to the power of 2 is equal to 4. Right? Apologies, let me change the pen, right? So 2 to the power of 2 is equal to 4, right? I'm asking for it in exponential form. So this here is in that exponential form, x to the n equals a form, so I am done, right? And something very easily with these type of problems when there's no variables is if you're nervous about it, you can always check in your calculator. And by that, I mean you could actually plug in 2 squared, hit enter, and see what answer it gives you. And it better give you the answer of 4, else, right? Else your form is incorrect, right? So it's a good way of checking yourself here. All right. If we go down to number 3 here, okay, same thing. What this is saying is 3 to the power of negative 4 is equal to 1 over 81, right? I'm not asking you to go any further than this, right? That would be something else, okay? So I could, though, of course, take this problem and have it be multi-step, right? I could say write this in exponential form. Then for this one, I could say write in simplified expressions or etc., right? I could ask for a lot of different things. I could say rewrite this in sig figs, okay? But essentially, the core of this problem is already done here, all right? If I look at number 2 here, I have log base 125 of 5 is equal to 1/3. So again, I have my base value raised to the power of my answer, and then my argument goes there to change forms. Again, same thing here, all right? Since I asked for it in exponential form, we are done. But we know that 125 to the 1/3 is actually a radical. So again, if I asked for something like in the simplest form, or I could say in radical form or whatever, right? I could ask, and that would turn this problem into here, right? And again, you could always go back and check in your calculator if it's got no variables. All right, looking at number 4 here, log base 2 of 7 to the 7/23 is equal to negative g. Again, I don't care what this looks like. I just need to change this back into its exponential form. So this is saying 2 to the power of negative g is equal to 7 over 23, right? This is in exponential form, all right? I'm not asking for a value of g that gives me this answer. I'm just asking for you to get me into this form. All right. Now, if we look at number 2 here, rewrite each into logarithmic form. So again, I'm just asking for a single value, single expression or equation that is in this form of log to the base, give me my argument, is equal to my answer. So zooming in here, okay, I have my base value of 4, okay, and to the power of 4 is equal to 256. So what this turns into is log, my base stays the same, but now my answer becomes my argument and my exponent becomes my answer. Okay, and that 4 being there, that guy going there, and this one going there. Okay, and again, I'm just asking for this expression, so we are done. If we look at number 9 here, again, same thing, log base of 6, okay? I write my argument of 136 to the power, is equal to negative 2, which was originally my power, right? And again, I am done with this expression. Okay, looking over here at number 8. Okay, so same thing, log. My base value is 243. My argument becomes 3, and that is equal to my answer of 1/5. And done. Okay. Same thing here with number 10. We're not asking to solve. We're just asking to rewrite it in a different form. So this turns into my log base S. My argument is 5/19. My answer now becomes -n. All right. So again, that's all I was asking for in number 2. All right. Now, looking at number 3 here, I'm having to simplify into a single logarithm. So again, all I want is a single logarithm in the form log base x equals a. That's what I'm looking for, a single logarithmic expression. So if I look here, all right, first off, I have logs with no bases. All right, so this is actually log base 10. If you're really nervous or concerned about it, I just want to rewrite that there. Okay, and this is again called our common log. Okay, it is totally fine that it is written without that base value of 10, right? So you do not have to write a base 10 there, but that is the assumed base when we see it written in this form. Okay, now in order to solve this problem here, okay, I already have 2 simplified logs, okay, and I have the addition sign. So I'm going to use my law of addition. Okay, and what that law of addition says is I have my logs, as long as they have the same base values, when they're being added together, they get multiplied together. So this is actually log base 10 of 24 times 25. And if I go into my calculator, what this turns into is log of 600. Or log base 10 of 600. Both of them are equally accurate. Okay, so either one of these answers could work. Now, that's all I asked for here. I asked to simplify into a single logarithm. If I asked you to solve for this problem, right? So again, extension question here, if I asked you to solve for our original expression of log 24 plus log of 25, right? Step 1 would be getting it into a single logarithm, right? So our form of log base 10 of 600, okay? Then step 2 would be to evaluate that expression. Basically then turning this into equals our x variable. And then we would solve for x. Okay? And we would solve for x by following the process. Right? By following the process of rewriting this into our exponential form. So 10 to the power of x is equal to 600. Now, unfortunately, in this problem, right, there is no appropriate answer for this, okay? There is no appropriate answer for this, but that's why this problem just asked us to get it into a single logarithm and not actually solve, okay? So, again, apologies that is the way that it is, but that's the steps you would take in order to do that. Now, going back to what this question originally asked, just getting these into single logarithms, okay? Apologies about the formatting. What this should have looked like is log base a of 28 minus log base a of 4. I'll make sure those are fixed for your test so there's no confusion on that, all right? Now, they have the same bases, okay? They're already in these simplified singular logarithmic expressions, so we're just going to use the law of subtraction. Okay, and what that law states, I have log of my common base, right? My same base between the two of them. And this turns into 28 divided by 4. Okay? Now, since 28 divided by 4 gives us a whole number, we're actually going to take this one step further and actually do 28 divided by 4, and that gives me 7. Okay, that gives me 7. Now, if I had my answer log base A of 23 over 4, okay, 23 over 4 doesn't simplify nicely, so we would leave this as is, because if I plug that into my calculator, I get out a decimal-based value. So since that is not easily simplified, we would leave our answer. But for this one in blue, okay, we can simplify 28 over 4, so we're going to do that. All right. Then here for C, okay, again, sorry about the formatting. This should be 2 log of A to the 5 minus 3 log of A squared. Or sorry, A to the power, oh goodness, let me read this again. So this is saying 2 times log base A of 5 minus 3 times log base A of 2. All right. Now, these expressions are different than the other ones because they have these coefficients out in front. So before we can even address that subtraction sign in the middle, we have to use our law of powers. Okay, we have to use our law of powers. All right. So what this would do here is we're going to take those powers and put them as exponents on our argument. So this turns into log base A of 5 squared minus log base A of 2 cubed. All right. Now, since we can actually evaluate 5 squared and 2 cubed, we're going to do that. Okay, so this turns into log base A of 25 minus log base A of 8. Okay. And for the sake of space, I'm going to go over here for my next step. Okay. But then my next step would be to actually address the subtraction sign. Right, so I'm going to then use my law of subtraction here. So I'm going to turn this into log base A of 25 over 8. Okay. And again, 25 over 8 does not reduce nicely, so we leave that as our final expression there. Okay. It does not reduce nicely, so we can leave the expression there. All right. And another example here, an additional example is if our final answer got to log base A of 6 over 9, okay? This would be a completely acceptable answer, all right? Or, as well, log base A of 6 and 9 can both be divided by 3, so this would turn into 2/3, all right? This would, of course, be its simplest form. So again, if I asked you to get me to the simplest form, it would have to be this one here where the fraction is 2/3 and not 6/9. Okay. Now, finally here for question number 4, we're kind of putting it all together here. We have to evaluate the following expression. So the first thing that we're going to do is we've got to get this into a single logarithmic expression. That is the trick to this. Get this into a single logarithmic expression. So if I were to write steps here, it would be single log. Then we're going to rewrite as exponential form. And solve, all right? Because essentially what we're saying is this is equal to what, right? This is equal to what? When we're asking to evaluate, we're asking to actually plug in and get a value for it, okay? So before we can even address any of the other steps, we first have to get this condensed into a single logarithmic expression. So if we notice here, I've got addition and subtraction and powers. So I'm going to address the law of powers first. All right, so this turns into And again, apologies. Let me rewrite this here before I simplify. This should have been log base 3 log base 3 of 40 minus 3 log base 3 of 10. Okay, apologies. So, same thing though. Those exponents are still going. So I have 5 squared plus log of 340 minus log 310 cubed. Okay. And similar to our other problem, we're going to actually plug in and solve for those variables. Right? So 5 squared turns into 25. Right? Plus log 340 minus log of 3. 10 to the power of 3 turns into 1,000 if we plug that into our calculator. Okay? Now what we can do is we can address these addition and subtractions. You can either do it as multiple steps or all in one step. And I'm going to do it all in one step here. All right? Essentially, these two are going to get multiplied, and this entire thing is going to get divided by this, right? Based on order of operations, addition and subtraction are on that same level, so we then work left to right. So what this turns into is log base 3 of 25 times by 40 divided by 1,000. All right. And I still got some room here, so I'll go one more. Oh, actually, I got room over here. So I'll go over here. All right. So this then turns into, if I do the, multiplication and division in my calculator, this turns into log base 3 of 1,000 over 1,000, or log base 3 of 1. All right. So now that I've got this in my single logarithmic expression, I can then rewrite this in exponential form and solve for what this is equal to. So again, this turns into is equal to x, right? This is the problem I need to solve for. So essentially, 3 to the power of x is equal to 1. What, if 3 is raised to the power of what is going to give me 1 here? And my answer is going to be 0. My answer is going to be 0. Because I can replug this back into my calculator, and it would give me that answer. And this is also one of our fundamental properties of logs. Right? It is one of our fundamental properties of logs. Okay? So again, that is the entire practice problems for logarithms here.